Okay, so let's talk now about shear centers. What is the shear center? It's actually a pretty important detail because if the shear force is applied at a point away from the shear center, it's going to cause twisting of the beam. So even though I applied this through the centroid like you might normally think I should do, this will cause the beam to twist. And I do not want my supports doing that. That does not look like a good idea to me. So the shear center is the point at which if you apply the force, it is not going to cause twisting. Now, this is not an issue with symmetric beams as the shear center and the centroid are identical. So we know how to calculate the centroid, we know how to calculate the shear center for those cases. It's not the case when we have an open section like this. So how do you find the shear center? Well, it's not terrible, but you are going to have to use those integrals we were talking about earlier. Remember when we wanted to calculate the force in the web or the force in the flanges, we had to figure out how to calculate them by integrating our expression for Q. So you have to figure out all those forces because what's causing this thing to twist is the moment that these forces cause. I apply a load P and that goes straight through the centroid, so it doesn't cause any twist. However, all three of these forces are causing it to spin around that centroid. All three of these forces are causing it to spin around that centroid. So if we can find a point where we can apply our force P that will not cause, will cancel out that torque, then we're good. So it might look something like this. Now for an open wall flange, you're like, what in the world? Yes, you have to apply a little plate here because the shear center is not even on the beam. Now we only need to calculate the z coordinate of the shear center as the shear force is assumed to be acting in the xy plane. It's not going to have any other components, it's just going straight down. So if we apply the load at this point, there's no longer a torque on the beam, and you can just calculate by looking and saying, okay, well, some of the moments around the x-axis are going to have to be equal to 2 times the force in the flange times d over 2, plus the force in the web times whatever our z-coordinate is of our centroid, and then subtracting off of that minus p times the eccentricity. And hopefully with that you will be able to solve for this. And when you do that, glorious day, it no longer causes any twist. So, I believe that's it for this section. Yes, it is. We're going into example. So, thank you all for listening. I'll see you all next time. Have an absolutely wonderful day. Bye-bye.